All right, so I want to talk about what is a reference angle. What is a reference angle? Okay, so if we think about drawing any angle, any rotation, let's just think about like a unit circle here. If we think about drawing any angle, okay, so let's say we have our initial side and we rotate somewhere. Okay, let's say we land right here. The reference angle is always going to be the acute angle, okay, that is formed by that terminal side that we just drew, okay, by the terminal side, and the x-axis. The x-axis, not the y-axis, the x-axis. Okay? Also, reference angles are always positive. We never think of those angles as negative. We just think of them as positive angles. Always positive. Okay? So if I was drawing this angle right here, and I said, okay, this is my angle, okay? The reference angle to what I just drew would be the angle from the terminal side I just drew all the way back down to the x-axis. So the reference angle would be that angle right there as a positive angle. So whatever that was, let's say that was 150 degrees, then the reference angle would be 180 minus that. It would just be 30 degrees here. Okay, so we would say, if this is theta, this is the angle that we just drew. Well, the reference angle to theta, we could just call this little angle right here, it's theta prime. Theta with a little dash next to it. Right? So our reference angle, no matter where we draw it, so if I put an angle, same thing, but let's say I put it in a different spot. Let's say it's in quadrant 3. So I go and my angle's over here. Okay, so let's say that I drew theta, and theta was from here all the way rotated to there. There's theta. Well, the reference angle is going to be, again, from the terminal side I just drew, and it's going to go back up to the x-axis. Okay, it's the acute angle. This one right here, right? That angle, let me put it in a different color. That pink angle right there, that would be theta prime, or the reference angle for theta, right? And if I put it in a different spot, let's say that theta is just really simple, just like right here. There's my angle. So I draw an angle, and let's say it's just like right here, maybe at like 45 degrees. There's theta. Well, the reference angle would basically just be the same thing, right? It's the angle formed by that terminal side back down to the x-axis, and it's just the same, it's the same angle, right? So this is also theta prime. They end up being the same exact value. All right, and if I put it, let's say, in the 4th quadrant, right? So if I do this and I rotate and it's all the way over here, let's say it ends like right here. Okay, so I just drew an angle from here all the way to here. Well, the reference angle to, let's call that theta, is going to be the angle that goes back to the x-axis, okay, in the shortest way possible. The acute angle, that would be right here. This little angle right there would be theta prime. We would consider that a positive value. Whatever that angle is, think of it as positive, and that's the reference angle. Okay, now of course, if your rotation is multiple, rotations, let's just say let's just say we have a point, or let's say we have an angle, and let's say it lands over here. And let's just say it happened to rotate like this. Like it was a big old angle. It was like some crazy rotation and it ended right there. Let's say that was theta. Well, the reference angle still is just going to be the simple idea that wherever it landed, the reference angle is still just going to be this acute angle going back to the x-axis. So that's theta prime there. Right, so that's a reference angle. So when we looked at, or when you had those problems on the unit circle, okay, so this sheet right here, and you had to draw out the angle and then give its reference angle. I know some people were kind of struggling on that because we didn't talk about it too much, right? So if we go over some of these problems with now that idea in mind, then hopefully it becomes easier to think about. So like for number 1, 225. 225, if I draw it, is like right, it's actually down here, right? It's that angle, which, right, for unit circle purposes, the terminal point is what, negative root 2 over 2 and negative root 2 over 2. The reference angle is just this guy right here, okay? What is that angle right there? Well, that's going to be 45 degrees, right? Because if we just look at it, right, if this whole thing, if theta is 225, and I'm trying to figure out just that little blue part, then I would take 225 minus 180, and I would get 45 degrees there. Or essentially, I'm just thinking, how much is that little angle right there? And you can just kind of reason through that. So when you draw the picture, it's easier to see sometimes what the reference angle is. And you can say, oh, it's 225 minus 180, because it's just 45 degrees past that 180 mark, right? So that's where we get the 45. So then if we, let's do the next one, right? 120 degrees, well, that's like over here, right? So that means theta is, if I drew it out, it's like from here to here. That's 120, okay? The reference angle to that would be going back to the x-axis right here. That acute angle, we're going to consider it positive. And we would say, well, that's got to be 60 degrees, right? This is 60 degrees for the reference angle. Because again, when we draw it, we are trying to find that little acute angle. And you have to reason your way through, well, what do I have to do to get that? I've already gone 120 degrees, so I have to go another 60 degrees to get back to the x-axis. So therefore, the reference angle is 60, okay? If we did number 3, we say 330 degrees. First we have to know where that is, right? 330 is going to be all the way around here, right? So even though we rotated, this way, the reference angle is the acute angle back to the x-axis, just that little gap right there. So if you draw it out, it's very easy to see that little tiny gap is 30 degrees. The reference angle is 30. We don't say it's negative or anything like that. We count it as positive. And, technically in that case, you could take 360 minus 330, right? But if you just draw it out, you can pretty much reason your way through, like, what is that little gap there? What do I have to subtract from or add to, to get back up to the x-axis of 30 degrees? Now again, what if we had a reference? Let's just do one more. Let's do one where it's like a radian right here. So let's just say number 8, 7 pi over 4. So 7 pi over 4. 7 pi over 4 would be, 7 pi over 4 would be all the way here. Half pi, full pi, 1.5 pi, and then 1 3/4 pi. 7/4 pi, like right here. Okay, so there it is. So 7/4 pi is like from here to here. What's the reference angle of that? Well, that's just going to be this little gap right here. Okay. If we keep our thought process or our angle in radians, we would basically just say, well, how many? I've gone 7/4 pi, right? I've gone 7/4 pi from here to here. How many more fourths do I have to go to get back up to the x-axis? Right? If I go 8/4 pi, which is 2 pi, then I'm already there. So I just have to go another 1/4 pi. That's the reference angle here. It's pi over 4. It's positive. There's just a pi over 4 there, and that's the reference angle. In fact, the thing about these special angles on the unit circle, whatever the denominator is going to give you a hint towards the reference angle, right? So like number 7, this is pi thirds. The reference angle is, in this case, is just pi over 3. Over here, since we have 5 pi over 6, right, which is over here, the reference angle is just going to be 1 pi over 6, right? Reference angle here is 1 pi over 6. This is 1 pi over 4. This is 1 pi over 3. So the denominator, whether it be a third, a fourth, or a sixth, quite simply just tells you, what type of reference angle you might have there.